Diaphragm pumps can be driven by different means. One type of diaphragm pump, a motor-driven diaphragm pump, relies on a motor and a mechanical linkage to operate. We can get a better idea of how this type of pump is designed and how it operates by using this illustration. Here we can see the flexible diaphragm positioned across a pumping area or cavity. The diaphragm is attached to a connecting rod, which in turn is connected to a motor-driven device called an eccentric. The eccentric and the connecting rod convert the rotation of the motor to a reciprocating motion. The suction and discharge valves are located underneath the pump cavity. The pump works like this. At the start of the suction stroke, the connecting rod is in its lowest position, and the diaphragm is flexed to its maximum downward position. As the eccentric rotates, it pulls the diaphragm upward, which creates a reduced pressure below the diaphragm. The reduced pressure closed the discharge valve, opened the suction valve, and drew liquid into the pump. As the eccentric continues to rotate, it forces the diaphragm downward to start the discharge stroke. The downward motion of the diaphragm exerts a force on the liquid in the cavity, which increases the pressure. The increased pressure closed the suction valve, opened the discharge valve, and pushed the liquid out of the pump. After the liquid is displaced, the diaphragm moves upward and the cycle starts again. Some diaphragm pumps rely on compressed air as their source of power. In these air-operated pumps, compressed air is used to create the reciprocating motion. We can get a better understanding of how this type of pump operates by looking at an illustration of a typical air-operated duplex diaphragm pump. Duplex diaphragm pumps are designed with two diaphragms that operate on alternating strokes. So when one diaphragm is drawing liquid into the pump, the other diaphragm is forcing liquid from the pump. Here are the two diaphragms inside this duplex pump. They are attached to each other by this connecting rod. The areas on these sides of the diaphragms are for the compressed air, and the areas on the other sides of the diaphragms are for the process liquid. The air valve, located here, simultaneously directs compressed air to one diaphragm and exhausts air from the other. Here are the suction valves for the liquid, and here are the discharge valves. During operation, the air valve operates to admit compressed air to one of the diaphragms. When the air enters this side of the pump, both diaphragms flex in this direction. When the diaphragms moved in this direction, the pressure of the liquid increased on the left side of the pump. This closed the suction valve and opened the discharge valve. On the right side of the pump, the pressure was reduced. This closed the discharge valve and opened the suction valve. So on this stroke, liquid was forced out of the left side and drawn into the right side of the pump. Then the air valve operates to allow compressed air to enter the right side of the pump and to vent the air that was applied to the left side of the pump. When this happens, the diaphragms flex to the right. This reduces the pressure on the left side of the pump. This caused the left discharge valve to shut and the left suction valve to open. At the same time, the pressure on the right side of the pump increased, which caused the right suction valve to close and the right discharge valve to open. So on this stroke, liquid was drawn into the left side of the pump and forced from the right side of the pump. The cycle continues as long as air is alternately supplied to and exhausted from both sides of the pump. In this topic, we looked at two common types of diaphragm pumps: motor-driven pumps and air-operated pumps. We looked at the basic construction of these two pumps and we saw how they operate. Now is a good time to try some practice questions about diaphragm pumps. The eccentric rotates and forces the diaphragm downward to start the discharge stroke. The downward motion of the diaphragm exerts a force on the liquid in the cavity, which increases the pressure. The increased pressure closed the suction valve, opened the discharge valve, and pushed the liquid out of the pump. When the diaphragms moved in this direction, the pressure of the liquid increased on the left side of the pump. This closed the suction valve and opened the discharge valve. On the right side of the pump, the pressure was reduced. This closed the discharge valve and opened the suction valve. So on this stroke, liquid was forced out of the left side and drawn into the right side of the pump. Pump startups and shutdowns are an essential part of basic pump operation. The procedures that we're about to see include some of the basic steps that are often followed during the startup and shutdown of one particular type of reciprocating pump. But keep in mind that startup and shutdown procedures can vary according to the process, the plant, and the pump that's involved. So you'll always need to follow the specific procedures used by your plant. This is the pump we'll use for our demonstration. It's an electric motor-driven diaphragm pump that's used to add chemicals to a wastewater treatment process. The amount of liquid discharged from the pump can be adjusted by this positioner. The positioner controls the amount of liquid that is drawn into the pump on each stroke. It's adjusted to control the amount of chemicals that are added to the wastewater treatment process. The flow paths into and out of the pump are controlled by a series of isolation valves. For this pump, there's an isolation valve for the suction and an isolation valve for the discharge of the pump. The first step in the startup of the pump is to ensure that it's properly lubricated. This involves checking the oil level in the lubricator. Once that's done, the flow paths for the pump are lined up. The suction valve is opened first. This establishes a flow path to the suction of the pump and allows liquid from the chemical tank to fill the pump. Once the suction flow path is established, the discharge valve is opened. This establishes the flow path out of the pump. With the flow path established into and out of the pump, the next step is to start the pump. Once the pump is started up, the operator checks the pump's performance. For example, the operator checks the operation of the positioner. Any problems with this component may require the pump to be shut down. It's also a good idea to check for leakage, unusual gauge readings, unusual noises, and excessive vibration. These conditions can serve as warnings about potential trouble with the pump. Now, as with a startup, the procedures for shutting down a pump can depend on several factors, such as whether it's being shut down to a standby condition or for maintenance. Since shutdown procedures can vary, it's important to know why the pump is being taken out of service and to follow the appropriate shutdown procedures used by your company. In this example, the operator receives word to shut down the pump. So he first stops the motor. This stops the movement of the diaphragm. Then he goes to the isolation valves for the pump. There he isolates the liquid flow path into the pump by closing the suction line isolation valve. Then he isolates the liquid flow path out of the pump by closing the discharge line isolation valve. At this point, all the flow paths into and out of the pump are shut off, and the shutdown is complete. Like all positive displacement pumps, reciprocating pumps try to deliver a controlled amount of liquid on each reciprocating movement. But if the discharge is blocked, the liquid won't have any place to go. If this occurs, pressure could build up and damage the driver, the pump, or associated equipment. A common type of protective device used to prevent excessive pressure is a relief valve. The relief valve is used to relieve discharge pressure that exceeds a predetermined value. This is an illustration of a typical relief valve installed on a pump. The relief valve body has an inlet port and a discharge port. Inside the valve body is a valve disc, a valve seat, and a spring. The inlet of the relief valve is connected to the discharge of the pump, while the outlet of the valve is connected to the pump suction. When the pump is operating normally, the liquid from the discharge of the pump fills the chamber below the valve disc. Liquid from the suction of the pump fills the chamber above the valve disc. During normal operation, the spring holds the disc closed on its seat. The discharge pressure of the pump applies force to the other side of the valve disc. If the discharge pressure becomes excessive, it overcomes the force of the spring. This will move the valve disc off of its seat and relieve the pressure from the discharge of the pump. When this happens, the liquid flows back to the suction side of the pump and recirculates through the pump. As long as the discharge pressure of the pump is above the predetermined set point, the relief valve will remain open. But when the discharge pressure falls below the set point, the spring overcomes the pressure that's holding the valve disc off of the seat and reseats the valve. In this topic, we looked at some basic procedures used to start up and shut down one type of reciprocating pump. We also saw how a relief valve works to protect a pump. Now let's try some practice questions. In this example, the operator receives word to shut down the pump. So he first stops the motor. This stops the movement of the diaphragm. Then he goes to the isolation valves for the pump. There he isolates the liquid flow path into the pump by closing the suction line isolation valve. Then he isolates the liquid flow path out of the pump by closing the discharge line isolation valve. At this point, all the flow paths into and out of the pump are shut off, and the shutdown is complete. During normal operation, the spring holds the disc closed on its seat. The discharge pressure of the pump applies force to the other side of the valve disc. If the discharge pressure becomes excessive, it overcomes the force of the spring. This will move the valve disc off of its seat and relieve the pressure from the discharge of the pump.